Hey, how's it going? Welcome to another MLittleProgramming tutorial. In today's video, we're going to be taking a look at recursion in Python, what recursion is, where we can use recursion, and how we can replace existing logical operators such as for loops and while loops in our code. We're actually going to look at two ways to write recursive functions. Some people find one way easier than the other, so make sure you stick around for both so you don't miss out. Please like the video and subscribe to the channel if you want to see more of this type of content. Let's jump straight into it. So, what is recursion? Recursion in computer science is a method of solving a problem where the solution depends on solutions to smaller instances of the same problem. Simply put, recursion is a function that calls itself. We can think of this like a Russian doll. You keep opening up the doll over and over again, each time finding a smaller doll inside. This process happens over and over again until there is the smallest possible doll with no other dolls inside, ending the process. Recursive functions have some requirements, often referred to as the three laws of recursion. The first is that it must have a base case. A base case is the termination point for the function. This is required because without a base case, theoretically, the function could continue calling itself forever. Second, a recursive function must change its state. This change in state must move the function toward the base case. This essentially means that a recursive function must have a parameter, so that our function could call itself with an argument that moves it closer to its base case. Thirdly, and an obvious result of the previous two laws of recursion, is that our recursive function must call itself. Recursion, like all programming paradigms, has some benefits and some drawbacks. We'll take the benefits first. Many algorithms can be expressed more elegantly using recursion. This makes your code easier to read by other people, which is important if you're working on a project in a big team. Recursion can also reduce the time complexity of an algorithm. This is because recursion by nature has decision-making control structures built in. This is because a requirement of a recursive function is that it has a base case asking whether the function should call itself again or terminate. However, there are a few drawbacks of using recursion. As I mentioned earlier, recursion can replace logical operators in our code. But recursion can sometimes be slower in its calculations due to the fact the processor has the overhead of maintaining a stack. A new stack is created for every function call, which is a greater overhead than the existing logical operators have. This means that recursion usually uses more memory for the stack than the existing logical operators. With recursion, it is possible to replace anything you write with a for loop or a while loop with a recursive function. Anyway, that's enough of what recursion is. Now let's get on to some examples. A real-life math example is 5 factorial. Don't worry if you don't know what factorial is, I'll explain as we go along. 5 factorial is written 5 exclamation mark. The factorial is all numbers multiplied together between 0 and the number we are finding the factorial of, not including 0. So in the case of 5 factorial, we would times 1, times 2, times 3, times 4, times 5. And so 5 factorial is 120. So if we look at 4 factorial, that is 1 times 2 times 3 times 4, which is 24. There is also a somewhat potential unexpected case if you are new to this, and that is 0 factorial. 0 factorial is 1. There is no need to go into detail about this in this video. It was mainly for the purpose of explaining how to write a recursive function so that we can work out factorials in the next example. So now we're going to hop into pycharm to write a function that can work out the factorial of a number that we pass into it. But first though, let's create a program that can work out the factorial of a number using a while loop inside a function. This is so that we can see how we can build a recursive function like an iterative program. If you want to learn more about while loops, I'll put a link in the top right now and a link down in the description. We're going to call our function getFactorial. Our function will have one parameter. This will be the number we want to find the factorial of. We'll call our parameter num. Inside this function, we're going to add two if statements. These if statements are going to apply those rules we know factorials follow. The first if statement is if the number we pass in is less than 0. If the number we pass in is less than 0, we're going to return an error, which is that we can't find the factorial of a negative number. The second is that if the number we pass in is 0 or 1, we know the factorial is going to be 1, so it's more efficient to stop the function here before we enter the while loop. Next, we're going to create a variable that's going to be called factorial, which we're going to initialize to 1. That will be the value we're going to keep track of what the factorial is of the number we pass in. Now we need to set up the while loop to actually work out the factorial of the value we pass into the function. In the while loop, we are going to check if the num is greater than 0. This is because inside the while loop, eventually we're going to decrease our num by 1 on every iteration. First though, we're going to multiply the factorial variable by our num on every iteration. To do this, we can use a similar syntax to how we increment numbers by 1 in a loop, but instead of the add symbol, we use the multiply symbol. Underneath this is where we're going to decrease our num by 1. I'll add a print statement so that we can see what's going on. So when we run this now, what we see is that on every iteration of our while loop, our num decreases by 1, and we times that with the value of the previous equation. This means that we are feeding a value that was calculated in the previous iteration as input into the next iteration of the while loop. This sounds like the description of recursion. We're breaking down our problem into smaller problems on every iteration, although here we're using a while loop, so this is not a recursive function. So I mentioned earlier that we can rewrite any piece of code that uses an iterative loop with a recursive function. Let's comment this first function we've written out and replace it with a new function. The function will have the same parameters, just the number we want to find the factorial of. Underneath that, our recursive function will have the same if statements as we did with the while loop solution to increase our efficiency. However, instead of our while loop, this time we'll have a catch-all else statement where the recursive magic is going to happen. This means that our second if statement is actually going to have to change to an else if statement. Back in the else part of our if statement, we're eventually going to want to return the value of our factorial. So we place a return statement in our else. In the return statement is where we're going to do the recursion. So, like in the while loop, we're going to want to multiply our number that we pass into the function by our running factorial counter. So, in our while loop equivalent, that was num multiplied by factorial, our running counter for the value that we were going to return as the result of the value of the factorial. Similarly, in this case, we're going to times our num value by a value that's keeping track of our factorial value. In this case though, that value is going to be a recursive function call, so we're actually going to ask the function to call itself here. However, the value we pass in as an argument is going to be the number we passed in originally, minus 1. We'll run that as before. What we see now is that this has the same result as the while loop version of this program. So what is happening in this recursive function? What is happening is this num value will decrease by 1 on every recursive function call, like in the while loop where num was decreasing by 1 on every iteration of the while loop. That value is being multiplied by the factorial of the number 1 less than it. So in the first case, the calculation is 5 times the factorial of 4. The factorial of 4 is 24, so this results in 120. In the second case, we passed in 5 minus 1 here, so the calculation is 4 times the factorial of 3, so 6, making 24. The program continues in this fashion until num gets to 0 and then the program stops. This is one way to write a recursive function in Python. There is actually a second way, as I mentioned at the start of the video. Some people find this method of writing recursive functions easier to understand when they're just starting to write their own recursive functions. I know I did when I just got the grips with writing my own recursive functions. This involves writing what are called auxiliary functions. Writing an auxiliary function is an additional function that we write, meaning our recursive function is actually two functions working together. Let's use this factorial use case that we've been using so far for the other example in this video, so that we can see a direct comparison between the two. An auxiliary function is useful when our recursive function requires extra parameters than what we passed into the initial function call. For example, in our factorial function, there comes a point where the numbers we're trying to calculate the factorial of take a long time to calculate. This means that the user of the program may think that the program is not working, so what we can do is inform them that the program is working by printing something such as loading. We are going to move the functionality from getFactorial to a new function called getFactorialAux. GetFactorial will still have the same parameters as we had before, as we are just going to pass in the number we want to find the factorial of. Inside the getFactorial function, we are going to have a variable, printLoading, which will initialize to false. After that, we'll have an if statement that says if the number we want to find the factorial of is 1000, set printLoading to true. Under that, from this function, we're going to return getFactorialAux. We're going to pass in the arguments of the number we want to find the factorial of, and the printLoading variable to the getFactorialAux function. From this point, our program works the same way as the previous singular recursive function. The only code left to write is to get this recursive function to print loading upon every iteration. To do that, we can write a very simple if statement, if printLoading, then print the string loading. Now when we call the function, we'll call it with the value 300, so we can see our loading functionality in action. So when we run this now, we'll see that the program will print a series of loading statements, and then when it is done, it will print the factorial number as before. The benefit of this method of writing recursive functions is that we can add more parameters to the function that's doing the recursion than the one we pass in the initial call. They work in a very similar way to singular recursive functions. We go from the call to this getFactorial function. Then we call our awks, which does some recursion and then returns a final calculation to our getFactorial function, which in turn returns a value to the place we initially called from. So hopefully that made a lot of sense, and now you can start writing your own recursive functions. Thank you for watching the video this far. I hope you got a lot of value from it. If you'd like to see more Python programming tutorials, there will be a link in the description down below to a playlist of Python programming tutorials. With that said, if you liked the video, if you could drop a like on the video, it would be much appreciated, as it really helps the channel, and subscribe to see new Python programming tutorials every week. Also, if you've got any questions about the video, drop a comment down below and I'll get back to you. Have a great day.